Hi, so we have this question and we have to convert from base 2 to base 10, 101.011 base 2, we have to convert that to base 10. So how do we do this? So I'd actually love if you could actually pause the video and try this out yourself. So to convert that to base 10, so we have to do it by expansion method. So we have to have 1 multiplied by the base, which is 2, plus 0 multiplied by the base, then plus 1 multiplied by the base, then you have decimal. Let me put that properly. So you have a decimal, then 0 multiplied by the base 2, plus the next digit 1 multiplied by the base 2, plus the next digit 1 multiplied by the base 2. Now you see the decimal, so this is where the decimal is. So I'm going to put a red line to break that off from that. So start with the one on my left hand side by giving the base 0, starting from 0, then 1, then 2. Then after the decimal to my right, I'm going to start with the base and I'm going to start with -1, then -2, then -3. So let's evaluate that. So any time you have after the base, after the decimal point, the bases after the decimal points are going to be taking a negative value starting from 1, -1, -2, -3, and so on. So I have 1 multiplied by 2 to the power of 2 is 4. That's 4 plus 0, 2 to the power of 1 is 2. Then plus 1 multiplied by 2 to the power of 0 is 1. Then I have a decimal. So I'm going to change that decimal, or let me just leave it like that, to the decimal point. Then I have 0 multiplied by 2 raised to the power -1 is actually 1 over 2 raised to the power 1, plus 1 times 1 over 2 raised to the power of 2 because of the negative index, then plus 1 times 1 over 2 raised to the power -3. So I'm sorry, not -3, raised to the power of 3. So the negative is actually becoming 1 over. So that's what we're doing. So 1 times 4, you have 4, plus 0 times 2, you have 0, then plus 1 times 1, you have 1. Then you have your decimal points. And so you have 0 times half, you have 0, plus 1 times all of that is 1 over 2 raised to the power of 2. Then plus 1 times this, I have 1 over 2 raised to the power of 3. Okay, so I have 4 plus this, I have 5 point, that's 1 over 4 plus 1 over 8. Okay, so I could write my answer in 2 ways. I could actually say convert that, okay, let me just write this out. 1 over 4 plus 1 over 4, if you find the LCM is 8, and of course we're going to have 3 over 8. 3 over 8. So I could write this 3 over 8 in decimal, and if I want to write that in decimal, or better still, I could write that in mixed fraction by saying 5 whole number 3 over 8, or I could write that as 5.3 divided by 8 is actually 375. So that's 375, and this is in base 10, and this is also in base 10. So that's how to convert from base 2 to base 10. Then we have this in base 8 to base 10. So 241.23 base 8 to base 10. So we're going to do that by expansion, and we're going to have 2 multiplied by the base, that's the first digit, 2 multiplied by the base 8 plus 4 multiplied by the base 8, then plus 1 multiplied by the base 8, then you have your decimal point, and I have 2 multiplied by base 8 plus 3 multiplied by base 8. So this is the decimal. I'm going to cut a line like this just to bridge that part, and I start from the left hand side. So left hand side, my next value is going to be on the power of the base. It's going to be starting from 0 to 1, then to 2. Then after the decimal to my right, I'm going to be having minus 1, minus 2. Okay, good. Then I'm going to have 2 multiplied by 2 raised to 8 raised to the power of 2 is actually 64, plus 4 multiplied by 8 raised to the power of 1 is 8, then plus 1 by 8 raised to the power of 0 is 1, then you have your decimal point, then you have 2 multiplied by 1 over 8 to the power of 1, then plus 3 multiplied by 1 over 8 to the power of 2. Okay, then 2 times 64. 2 times 64 is 128, plus 4 times 8 is actually 32, then plus 1 times 1 is 1, then you have this decimal, then you have 2 divided by 8, 2 here 1, 2 here 4. Okay, so I'm having 1 over 4 plus 3 over, that's 3 times 1 is 3, over, what's the base? 8 raised to the power of 2 is 64. Okay, and so I'm having 128 plus 32 plus 1, that's 161, 161. Then you have your decimal point. Then if you do that, your LCM is actually 64, and if you do 1 over 4 plus 3 over 64, you're going to get 19 over 64. 19 over 64. So I could write this in 2 ways. I could write it in mixed fraction or in decimal. So I could have 161 whole number 19 over 64, or I could write it as 161.2969. So 2969, and all of these has to be in, they have to be in base 10, and likewise this also has to be in base 10. So that should be your answer for that particular problem. So there we go with this one. We have 9 whole number 7 over 8 base 10 now to base 2. So how do we convert this from base 10 to base 2? So I'm going to start with different digits. So I have 9 plus 7 over 8 would actually give us 9 whole number 7 over 8. So I'm going to do this separately. 9, and I'm going to do 7 over 8 separately. So I'm going to start with 9. So 9. Let's do 9. Let's convert 9 to base 2. 9 to base 2. 9 divided by 2, you have 4, remainder 1. Then 4 divided by 2, you have 2, remainder 0. And then 2 divided by 2, you have 1, remainder 0. And 1 divided by 2, you have 0, which is impossible, remainder this guy here, 1. And to that effect, 9 to base 10 is actually 1001 base 2. So I'm going to keep this. And that's equal to 9. Okay, now I'm going to pick 7 over 8 base 10. So I'm going to convert that to base 2. So this is 7 over 8. And besides, I know it's 2 raised to the power of 3 that gives me 8. And this is in fraction. So what I do is I'm going to do 1 over 2, or better still, after this is 7 over 8 is actually 0 point something, so decimal. So I'm going to have 2 to the power of minus 1 plus 2 to the power of minus 2 plus 2 to the power of minus 3, because 2 raised to the power of 3 is 8. So I'm going to stop there. So writing this in fraction, I'm going to get 1 over 2 plus 1 over 2 raised to the power of 2 is 4 plus 1 over 8. If I do the LCM of this, would I get 7 over 8? Let's try that. LCM is 8. 8 divided by 2 is 4. 4 times 1 is 4. Plus 8 divided by 2. You have 8 divided by 4, you have 2 times 1 is 2. Then plus 8 divided by 8 is 1. So I have 7 over 8. So, but then there has to be coefficient to this number. So in that case, I'm going to add the coefficient. Since everything just falls in place, I'm just going to have 1, that's by 1, 1 by 1, and 1 by 1. So therefore, this 7 over 8 is actually 0.111 base 2. That's 7 over 8. 0.111 base 2. Now, 9 plus, coming back here, you have 9 plus 7 over 8. So what's our 9? Our 9 is 1001. And our 7 over 8 is this. So I'm going to join the two together. So basically my final answer has to be 1001.111 base 2. So I've combined these two together, and what I get is this guy here. So this is my final answer. So now we are given 9 over 64 base 10 to base 2. So how do we do that? Now the first question you should ask is 2 raised to the power of what? So I'm converting to base 2. 2 raised to the power of what will give us 64. So that will be 2 raised to the power of 6 will give us 64. Okay, so the first thing I would first do, first I'm going to first do is to actually convert. Okay, you can do it two ways. You can actually use the first method I used before, Or you could just divide straight 59 to base 2. 59 to base 2. 59 to base 2. 59 divided by 2. But 59 divided by 2 is actually 29. Remainder 1. Then 29 divided by 2, you have 14. Remainder 1. And you have 14 divided by 2, you have 7, remainder 0. And 7 divided by 2, you have 3, remainder 1. And 3 divided by 2, you have 1, remainder 1. And 1 divided by 2, that's impossible, so you have 0. Then you have this remainder here, and you have remainder 1. So I'm going to take that from the top, from the bottom to the top. So my final answer is going to give us 1, 1, 1, 0, 1, 1, base 2. So since it's 59 over 7, since it's 59 over 64, and that's basically fraction, so I'm going to add, that's not even up to 1, 0.111011 base 2. Okay, that's our final answer. So let me just take it back to the previous example that we had. Look at it, we have 7 over 8. So we could actually convert 7 to base 2. How do you do that? So let's convert 7 to base 2. See what I'm talking about. So 7 divided by 2, you have 3, remainder 1. Then 3 divided by 2, you have 1, remainder 1. And 1 divided by 2, you have 0. That's impossible. So you bring this guy here. You bring it here. So you have 1, 1, 1 base 2. So that means 7 over 8 is actually 0.111 base 2. So the same thing as this. So you could actually use this particular method. So here we go with this question. 321 base n is equal to 232 base 7. Now, since both of them are equal and we don't know what this particular base is, and both of them are equal, so it's better to make them on the same base, that's base 10. So let's just do that in base 10. So to convert this to base 10, I'm going to have 3 multiplied by the base, which is n, we don't know what that is, plus 2 multiplied by the base, which is n, plus 1 multiplied by the base. I'm going to give the base's power 0, 1, and 2. So, and that equals to, convert this also to base 10, that's 2 multiplied by the base, which is 7, plus 3 multiplied by the base, which is 7, plus 2 multiplied by the base, which is 7. So we have 0, 1, 2. Okay, then continue. That's n squared, 3n squared, plus 2n, plus 1. N raised to power 0 is 1, times 1 is 1. And that equals to 2 times 7 squared is 49, plus 3 times 7, plus 2 times 7 raised to power 0 is 1. So I have 3n squared plus 2n plus 1 equals to 49 times 2. 49 times 2 is actually 98 rather, plus 21, that's 7 times 3, then plus 2. Then I have 3n squared plus 2n plus 1 equals 98 plus 21 plus 2 is actually 121. So I'm going to have 3n squared plus 2n plus 1. Then take this to the other side. I have minus 121 equals to 0. And so I have 3n squared plus 2n minus 120 equals to 0. So I have this quadratic equation, and how do I solve this quadratic equation? Okay, we could actually use the different methods to solve quadratic equations, but let's use the formula method, and that gives us x equal to minus b plus or minus square root of b squared minus 4ac over 2a. So in this case, our a is 3, our b is 2, and our c is minus 120. Okay, so what's our x? Our x now becomes minus, what's our b? Our b is 2 plus or minus square root of b is 2, that's 2 squared minus 4. What's my a? My a is 3. What's my c? My c is actually minus 120. So close that. Then all divided by 2. What's my a? 3. Okay, and that gives us minus 2 plus or minus square root of 4. So minus times minus give us plus. So you have 4 times 3. 4 times 3 is 12. You have 12 times 120. And that's 1,440. 1,440. Then divided by 2 times 3 is 6. Then I have x now becomes minus 2 plus or minus square root of 1,440 plus 4. I have 144, 1,444. Then divided by 6. And so I have minus 2 plus or minus square root of 1,444 is 38. Then 38 divided by 6. So my answer is actually x is equal to minus 2 plus 38 over 6, or minus 2 minus 38 over 6. So then I have x equals to minus 2 plus 38 is actually 36 divided by 6, or minus 2 minus 38 is actually minus 40 divided by 6. And so I have x is equal to 36 over 6 is 6, or minus 40 divided by 6. So I'm going to have minus 6.667. So now we know that base cannot be a negative number. Base number can never be a negative number. So this here is cancelled. So our only option to that question is actually this x is equal to 6. So n in this case, the base in this case, n is equal to 6 in this case. So that's it.